NASA's discoveries are incredible. A molecule produced exclusively by living organisms has been detected on a planet 124 light-years away, a mysterious cosmic signal that pulses every 6.5 hours for which there is simply no explanation, and a black hole so close to us that even astronomers couldn't believe what their data was showing them. We're taking a very close look at this, and we're diving right in. Imagine standing on the beach and breathing in the fresh sea air. The characteristic smell of the sea comes from a compound called dimethyl sulfide, or DMS for short. On Earth, this substance is produced by marine plankton and is considered a clear biomarker, that is, an indication of biological activity. And it is precisely this substance that may now have been detected on an exoplanet named K2-18b. This exoplanet is only 124 light-years away from Earth, a mere stone's throw, cosmically speaking. It is 2.6 times larger than Earth and has about 8.6 Earth masses. The exciting thing about K2-18b is that it orbits its star, a red dwarf, in the so-called habitable zone. As early as 2019, the planet made waves in the scientific community when researchers discovered water vapor in its atmosphere. And even back then, scientists wondered whether K2-18b might be a so-called Hycean planet. This hypothetical class of planets describes worlds covered by a gigantic ocean and enveloped by a hydrogen-rich atmosphere, essentially a planet whose surface consists entirely of water. In 2023, a team led by Dr. Niku Madhusudan of the University of Cambridge caused a stir when they used the James Webb Telescope to study the planet's atmosphere and discovered not only water vapor but also carbon dioxide and methane. But what appeared at the time as only a faint signal and was doubted by many scientists was a first trace of dimethyl sulfide, the substance that is produced on Earth mainly by marine plankton. It has been determined with 99.7% certainty that this is not a random signal. The team hopes to achieve a 5 sigma detection with an additional 16 to 24 hours of observation time on the James Webb Telescope, the scientific gold standard which would reduce the probability of a random signal to 0.006%. However, it is almost certain that we have already detected dimethyl sulfide on an exoplanet. But does this mean we have proven the existence of extraterrestrial life? Possibly yes, but caution is warranted. Even though DMS is primarily produced by living organisms on Earth, non-biological processes could potentially be at work on an alien planet with completely different environmental conditions, generating the compound. In fact, last year DMS was even detected in the dust and gas of the definitely inanimate comet Churyumov-Gerasimenko. Furthermore, there is another strange aspect to this discovery. The measured concentration of DMS on K2-18b appears to be about 20 times higher than on Earth. This could indicate that massive processes are underway that produce this compound, whether biological or not. We should also bear in mind that K2-18b is not an Earth-like planet. While our Earth has a solid rocky core and is surrounded by a thin layer of atmosphere, K2-18b looks quite different. With its radius and mass, it is closer to Neptune than to Earth. Its enormous gravitational field would make life as we know it impossible. Life forms there would have to cope with pressures many times greater than ours. And there are even alternative explanations for the planet's composition. Christopher Glean, a planetary scientist at the Southwest Research Institute, recently released a preprint suggesting that K2-18b might have a massive magma ocean surrounding a large rocky core. The discovery also raises interesting questions about the habitability of planets orbiting red dwarf stars. For a long time, scientists believed that these stars could be quite problematic for life, as they tend to have violent eruptions, especially in their early years, that would literally boil away the atmospheres of nearby planets. If K2-18b does indeed harbor life, that would mean that red dwarfs, after all the most common type of star in our galaxy, accounting for 73% of all stars, could very well have life-friendly planets. And that is an exciting prospect, since about 80% of these stars have planets in the habitable zone. But if most habitable planets are massive ocean worlds with enormous gravity and no landmass, then organisms living there could literally be trapped in their oceans. So it's a fascinating thought. The universe could be teeming with life, but complex, intelligent life forms might not be able to evolve further because they're trapped in the ocean. Thank you, dear evolution, for making us land-dwelling creatures. Let's now turn to the next chapter of mysterious discoveries. Using the ASKAP radio telescope in Australia, scientists initially observed an unusually strong radio signal, but what they then discovered left even experienced researchers in awe. The signal repeated itself every 6.5 hours with astonishing regularity. "We've never seen this kind of periodic signal before," says lead researcher Manisha Caleb of the University of Sydney. The astronomers christened the mysterious object with the melodious name ASKAP J183907756. We'll stick with ASKAP. Normally, radio signals in space are emitted either by very fast pulsing neutron stars, known as pulsars, or by distant exploding stars. But ASKAP doesn't fit into either of these categories. Its radio signals are far too slow for a pulsar, and at the same time, the object is far too close to be a distant cosmic explosion. What's particularly fascinating is that researchers were even able to observe a so-called interpulse signal. This means that ASKAP not only emits a main signal every 6.5 hours, but also a weaker secondary signal in between. Furthermore, the strength of the signals appears to decrease over time. Over the course of 6 months, the signal grew weaker and weaker until it finally disappeared entirely. However, the scientists have also proposed a few other exciting theories. One possibility is that it is a particularly slowly rotating neutron star. These are the ultra-dense remnants of a supernova explosion. However, ASKAP would then be by far the slowest rotating neutron star we know of. Another idea is that we might be dealing with a so-called magneta. These are neutron stars with extremely strong magnetic fields. Some magnetars do indeed emit irregular radio signals, but even for that, the signal would be too slow. The researchers are also speculating whether it might be a binary star, but that wouldn't explain all the observations either. And it gets even more curious because another exciting property of ASKAP is its extremely strong polarization. The emitted radio waves thus oscillate in a very orderly manner in a specific direction. This points to enormously strong magnetic fields. In addition, the astronomers observed that the wavelength of the signal changed over time. At lower frequencies, the signal was broader than at higher ones, an effect also known from pulsars. ASKAP combines characteristics of various known phenomena but does not fit into any of the established categories. The researchers at least rule out an extraterrestrial signal. The signal's properties simply align too well with natural astrophysical processes. Even if we do not yet fully understand what is going on there, the researchers are observing the object with various telescopes in the radio, infrared, and X-ray ranges. But apart from the mysterious radio signals, nothing could be seen in any other wavelength range, and at some point the signal disappeared completely. For several months, nothing could be heard. The researchers were already afraid they had missed their chance to solve the mystery. But then, as if out of nowhere, it reappeared. Weaker, yes, but still with the same enigmatic period of 6.5 hours. This on and off behavior reminds astronomers of a class of objects discovered only a few years ago, so-called long-period radio transients. These are celestial bodies that emit radio signals for a period of time at irregular intervals and then fall silent again. However, none of these known transients has a period as precise as ASKAP's. This discovery could fundamentally change our understanding of stars and their evolution. At the very least, we must consider that we are far from knowing all the objects out there. And the next discovery is also incredibly extreme. Do you remember Hyades? For a long time, this red supergiant was considered the largest known star in the cosmos, and it really is awe-inspiring. It was originally estimated to be about 1,700 times the radius of our Sun. If placed in our solar system, that would mean it would extend almost as far as Saturn's orbit. However, more and more astronomers are questioning this size, as it's possible that the distance from Earth to Hyades was measured incorrectly. There are already estimates that reduce its radius to just 775 solar radii, but there are even bigger giants out there. In recent years, it was assumed that Hyades had been dethroned by Stephenson in 2018. Stephenson was estimated to have a radius 2,158 times that of the Sun. That corresponds to roughly 10 billion times the volume of the Sun. If you were to zoom around the star at the speed of light, it would take you 9 years. By comparison, it would take only 14.5 seconds to circle the Sun at the speed of light. But here's the thing, something doesn't quite add up with this radius, because the question of how large a star can theoretically become is quite complex. There are theoretical limits to stellar growth based on factors such as the star's composition, its evolutionary history, and the strength of its stellar wind, and it is assumed that this limit on stellar growth lies at about 1,500 times the radius of the Sun. Beyond that, the star could no longer exist in a physically stable state. For Stephenson, this means that either our measurements are incorrect, or that Stephenson is much smaller than we thought, but is surrounded by a gigantic outgassing cloud, and that we inadvertently measured the size of this cloud rather than the star itself. The diffuse gas in the outer layers of Stephenson 218 is therefore likely to have merged with the interstellar medium and can thus no longer be considered part of the star's surface. In other words, there is strong evidence that Stephenson is also much smaller than we thought. But there is another supergiant that was recently discovered, WOHG 64. It is a red hypergiant in the Large Magellanic Cloud, a satellite galaxy of our Milky Way. This star is not only large but also extremely luminous and cool. However, it is also a very peculiar star for other reasons. It likely has a smaller star as a companion, which would make it a binary star system. It has also been observed that it is losing an enormous amount of matter, with an average mass loss rate that ranks among the highest ever observed in a red supergiant. It is thus in the final phase of its stellar existence and is now, in its death throes, blowing its plasma into space. Some estimates put its radius at 2,575 solar radii. Incredible, but of course, one could again argue that this is physically unlikely. Nevertheless, it's clear that, including the outflow cloud, it is definitely larger than Stephenson. Slightly more conservative estimates put it at 1,540 solar radii, and that fits quite perfectly, as it places us right near the theoretical size limit for stars, and WOH will likely explode as a supernova in about 1,000 to 10,000 years, and that will be really intense. Of course, black holes are an essential part of the latest galactic discoveries. With their massive compressed mass and density, they create a singularity from which not even light can escape. Even with the best telescopes, we cannot peer into the center of black holes. After all, where light can no longer escape, we can no longer perceive any visual information. This makes this new discovery all the more spectacular. A black hole near Earth, and I mean really near. You've surely seen the constellations Orion and Taurus in the night sky before, and in Taurus lies the Hyades star cluster, which is even visible to the naked eye on very clear nights. The Hyades are an open star cluster that forms the V-shaped head of Taurus and is located just 150 light-years from Earth. This star cluster comprises more than 700 stars and stretches through space in an irregular, loose arrangement. The Hyades also have two so-called tidal tails, long stretched-out regions where additional stars are dragged along with the cluster, and 150 light-years is really just around the corner on a cosmic scale, because you have to remember that our galaxy, the Milky Way, is at least 100,000 light-years in diameter. Researchers have long suspected that there is a black hole in the Hyades. This is because many black holes form from massive stars that end in spectacular supernova explosions. At the center of star clusters like the Hyades, there are many massive stars that are highly likely to become black holes after their supernova. However, discovering black holes in open star clusters poses quite a challenge. The effects of black holes are harder to detect in the movements of the stars, which is how they would normally be easily found. Now, a team from the University of Barcelona has really dug deep into the data from the Gaia telescope, and what the researchers found in this data is mind-blowing. The simulations suggest that there could be at least 2 to 3 stellar black holes at the center of the Hyades. These black holes could be located either still at the center of the star cluster or in its immediate vicinity. But could black holes this close also influence our solar system? In our immediate cosmic neighborhood, that could very well be the case. However, there is no direct threat, because these are only stellar black holes and not supermassive ones like the one at the center of our galaxy. Instead of several million or billion solar masses, we're talking about a few hundred at most. 150 light-years is still a safe enough distance for such stellar black holes. So there is no reason to panic. Instead, we should rejoice that we can study these objects more closely since they are so near us. We live in an age when the James Webb Telescope is detecting chemicals on alien planets, when mysterious signals are pulsing from space, and when we're slowly beginning to grasp the incredible secrets our own galaxy still holds. And believe me, things aren't going to get any less exciting in the future. Subscribe now so you don't miss out on any more astronomical discoveries down the road. And while we've been gazing at the stars today, there's something right on our doorstep that's keeping scientists just as busy. Our oceans are currently sending out warning signals. A major ocean current has unexpectedly stopped flowing, with potentially serious consequences for our entire planet. We'll explain exactly what's happening there in the next video. It's very, very exciting. And if you'd like to get your hands on the galactic Astro-Tim shirts from the Plush Planets videos or Real Meteorites, feel free to check out the Space Shop in the bottom left corner. Every order supports the channel tremendously. Otherwise, I'd say see you in the next video. Take care, everyone.